Any questions?
Yes. Let me just pull up the question.
Is this gonna be, oh, I grabbed the wrong book here. Is this gonna be one from the textbook?
Yes.
All right, why don't I go grab the textbook? All right, your question?
It's loading.
It's what?
It's
Loading?
loading, yeah.
So in one of my videos, I use the girl from Ipanema as background music. I do like a little segment of it, and then I break, and then look at another segment. And so YouTube sends me a notification saying that's a copyright violation, which it was. So any money that they make off that video will potentially go to whoever owns the copyright. I thought, that's fair. I'm not claiming it's my music. But I appreciated the fact that they didn't just shut it down. Welcome, Benjamin. Right now, we're waiting for Sarah's computer to load some document. Should we just do the flash quiz and then bring that up, or now that Benjamin's here?
Okay, it's loaded.
All right.
Okay. So for the first question,
The
no,
number
not,
8?
no, not the first question. Oh, no, for question 66.
All right, uniform electric field passes through a closed surface?
Yes.
That one, okay.
So the equation says the electric field times the area cosine theta, and it was 1.1 meters times tan 40 degrees times 0.5. That's the area of the slanted surface.
That's the area of the surface that's, I guess, facing us in the textbook.
Okay. What is the process behind that? Like, how come it's tan 40?
All right, so we have, it's passing in the I-hat direction. I am closed surface, slant top. All right. X, and I assume Y, Z. And the object is basically coming, one edge is on the Y-axis, one edge, or one surface is in the XY plane, and then there's this other bit that comes up like that, which I am assuming is parallel to the YZ axis. So if we look at it from the side, this space right here is this space right here, and that's a 40-degree angle. They say that this is 0.5 meters, they say 50 centimeters, I believe, but, and this is 110 centimeters or 1.1 meters. And so if that's the case, that's 0.5 meters. And so this side over here would be, so tangent is opposite over adjacent, so this would be 0.5 times the tangent of 40 degrees. So it's that length right there. Do they have tangent, or they had some, what trig function they throw in there?
Yeah, they put tangent.
Tangent, okay. So do I have a wedge here? Don't. Are you having difficulty visualizing it?
Why do they use tangent? Because we're trying to find the hypotenuse, right?
No, they're trying to find the area of this surface right here. Because the electric field is coming through this slanted surface and coming through this surface.
Okay.
So you'll find the electric field, let's see, given the dimensions and orientation of the closed surface, the electric flux through the, through the slanted top, sorry. So that's 40 degrees. This length right here would be 0.5 times the tangent of 40 degrees. So through the slanted top, we have an electric field coming in that way. The area vector here is this way, because it is a closed surface, right? Yeah, it's a closed surface, so the area vector points outwards. So the area of this would be 1.1. So 0.5 over the hypotenuse, that's h, is equal to the cosine of 40 degrees. So h would be 0.5 over the cosine of 40 degrees. And they have 0.5 times the tangent of 40 degrees?
Yeah.
Times 1.1?
Yes.
Times?
Cosine 0 degrees.
That's cosine of 0 degrees? Times 1.57. Wait, let me see how the solution set up. Maybe I'm misreading the picture. Oh. Yeah. All right. They sort of work backwards. I know that the total flux through the surfaces so this is the total electric flux through a closed surface is equal to the enclosed charge over epsilon sub naught. There is no charge inside. So I know the total flux through the surface has to be 0.
So there's no charge inside because they didn't say that there was a charge inside?
Correct.
Okay.
And so from a side view, as the electric field is coming in through this, I know that the area vector here is pointing up, pointing at that 40-degree angle, or 50-degree angle, whichever one. And this one, area vector is pointing this way. Just call that A1 and A2. That's my electric field. Since there is no electric flux through the sides, because the electric field is perpendicular to that, this will be some positive flux, that'll be a negative flux. So, since those are the only two which have any flux at all, and the total has to be 0, if I find this, that just has to be the negative of it.
Okay.
So what they did is they found if I call that surface 1 and surface 2, they found, so that'd be the flux of 1 plus the flux of 2 equals that. So the flux of 1 is equal to the negative flux of 2, or actually, the flux of 2 is equal to the negative flux of 1. And the flux of 1 would be the negative, the electric field going through it, dot the area vector. And the area of this side right here, that's why the tangent pops into it. Because the height here is 0.5, tangent of 40 degrees. The width, or whatever you want to call that one, is 1.1 meters. So you multiply it to get the area with the area vector in the I hat direction. Or
Okay.
so they found the flux through the slanted surface by finding the flux through the flat surface.
So they just found the area of the vertical side of
Of the vertical side? So, yes.
Oh.
Yeah. Other questions? Let's just get the flash quiz underway. I'll ask again after that if there are any other questions. You probably don't want the chapter 23 one. And probably want the flash quiz first, since that's what I said.